We've seen the concept of doing a ring flip or a chair flip on a cyclohexane ring, but the process is more understandable if we consider a cyclohexane ring with substituents, because we can see how atoms are changing equatorial versus axial positions. So we're going to work through this problem and see how it works. The first thing you want to do is realize or identify the positions that the substituents are in. So for the bromine, this is going to be axial, but we can also say it's a up axial, or put that in parentheses, because it's pointing up above the ring in an axial position as opposed to below. As for the ethyl group on the left, this is going to be an equatorial position. I'll put EQU, period. But is it more of a down equatorial position or more of an up equatorial position? In this case, we'll say that it's down, because as you can see, it slopes downward. It's not as obvious as the axial positions, but you should get the idea. Next thing we'll want to do is number a few of the carbons on the cyclohexane ring. Now, this numbering system, you can start anywhere you want. It's just to keep track of where we want to put our substituents and to keep track of the correct carbons. So here's how we do the process of doing the chair flip easily. What you'll want to do is redraw the same carbon skeleton that you did on the left. Then what you want to do is, you see on the numbering system I have one starting here. Well, in this case, what we're going to do is we're going to shift the numbers either a carbon left or a carbon to the right, or a carbon counterclockwise or a carbon clockwise. So what I'll do is I'll shift the numbering system over 1 to the left. So I'll have 1 here, 2 here, 3 here. We just move the numbers. These aren't different carbons in any sense, it's just the numbering system, because we're keeping track of the carbons you want to put the substituents on. So what we do is we know that the bromine, this numbering system allows us to say, okay, the bromine is going to be at this carbon right here. So we need to figure out, okay, what's it going to look like after the chair flip? The main concept to understand is that we'll go from an axial position to an equatorial position, or vice versa. And since bromine was axial in this case, then it's going to be an equatorial position. And if you're comfortable with the way chairs look and drawing all the positions, then the equatorial position on carbon atom number 1, once you've done the flip, is going to be right here. It almost kind of goes out into the plane back towards the screen. And I'll go ahead and put bromine here. So now, what about the ethyl group? Well, we know that nothing is on carbon 2 because nothing was here, and that's going to apply the same thing here. Remember, these are the same carbons. We haven't moved the bromine over. We haven't changed its bond over left to a different carbon. But on group number 3, that's where we're going to put our ethyl group, right here. Well, it was in an equatorial position, so we need to put the ethyl group on the axial position on carbon number 3. Well, in this case, you can see that the axial position is actually going to be pointing down, because after all, if I kind of redraw this part of the ring on the left, it kind of looks like it's pointing down, like kind of pointing down arrow, and represents, the rest of the ring. So once we've done that, we've successfully done the chair flip. And the process we used is we numbered where our substituents were. We moved the numbering system over to the right one and changed the positions. And this represents what the chair flip looks like. It looks like we're just moving atoms around, but that isn't the case. To prove that we've gotten the right answer, I can say, okay, I'll turn this ring around this way, and if we were to redraw that up above, well, the chair would look a little bit different. It would look like it was going on to another side. And forgive that's a bad chair conformation I drew. Well, if we follow the carbons here, and say, okay, if we turned it more this way and put, let's see, 1 here, 2 here, and 3 here, well, I still just draw the same things, where I'll have the bromine is in equatorial position on group 1, carbon 1, and the ethyl group is in an axial position on carbon 3. So here, up and down hasn't changed at all. It's still the same things. I just turned the molecule around. But you can see how the chair flip happened, where it looks like, on the left, this, what looks like a pucker, kind of moved down, while this one moved up, getting us this rotation of single bonds that gets us the chair flip. So once again, the key concepts here that we're approaching with the chair flip is that when we have the chair flip, we're going from an axial position to an equatorial position, or vice versa. And in here we used a numbering system to help us keep track of where the carbons were, because when you drew the chair conformation on the right, it changed how we were looking at it. We were looking at the molecule from a different angle. And the numbering in general helps you keep track of where your atoms are when you're thinking of things in 3D, or you're trying to keep track of looking at molecules from different angles.